So, welcome to the Grasshopper ADD workshop. Just so I can kind of scope out a bit, how many of you have used Grasshopper before? 1, 2, 2.5, 2 3/4. Okay, good stuff. So, you're in the right place, right? So, this session is about the bare basics of Grasshopper, right? So, by the end of the session, you should understand what Grasshopper can be used for, and you should be able to put some basic scripts together, right? So this is what we call vanilla Grasshopper. We're not working with any more plugins or anything external. We're just working with the native nodes, what Grasshopper has to provide, okay? So what is Grasshopper? What can you achieve using it? We're going to be talking about parametric modeling. What is parametric modeling? And then we're going to have a hands-on tutorial, okay? We're all going to build our first parametric tower. Right? So I'm interested to see when we will get that. Right? So the point is not the outcome today, right? So we're not going to be designing the best tower ever, but we're going to be learning how to design something that's relational and dynamic. Okay? So I've tried to include the fundamental things you need to understand in this workshop. I have Nicholas joining me today. A lot of you know Nicholas. Are you joining as well? So we have Reggie as well. I want this to be interactive because if I reach halfway through and you still really didn't understand the previous things we talked about, it'll be very hard for you to continue, okay? So ask us questions. If there's a general question or something that's not very clear, we'll pause and then we'll explain it, okay? But it's important for us to get that second feedback loop, right? So if you're stuck, if you don't understand something, probably everyone else doesn't, so please let me know, right? Because I don't want to carry on, waste everyone's time, waste my time, and then we end up with a workshop that's not as successful as we want, okay? So, it's a basic screenshot from Wikipedia. So Grasshopper is a visual programming language, okay? So, and this is very important to understand because we've all seen the Matrix in movies like this where people are kind of typing. We see all these texts, and we understand that as programming, right? Grasshopper is also programming, okay? But you're programming in a different way. You're not using syntax, so you're not using Python or JavaScript or anything else. You're using nodes and edges, which will explain how to develop them, right? So I want you to think of this as really a way of you to program in scripts, but you'll be working with geometry rather than text. Grasshopper is a plugin for Rhino, right? So it builds on Rhino as a software. Rhino works with geometries in different ways. We're going to be talking about it very lightly, but I want you to understand that Grasshopper is in top. So anything you learn in Rhino will be somewhat transferable to Grasshopper and vice versa, okay? So something you learn in Grasshopper, you actually should be able to do to some degree in Rhino if it's a simple command. So why do you use Grasshopper? It's not because we want to design some fancy shapes, we can do that, right? But it's actually a very powerful design tool, right? And by design tool, I mean something that you can use at the beginning of your design process. So if I was to compare it with Revit, Revit is not a design tool, right? Revit is a documentation tool. So you design a building and then you put in Revit to get plan sections, elevations. Grasshopper can be used in the design stage, not in the outcome stage. So if you see some diagrams like this would have been developed using a program language by, if you think in very simple terms, you're arraying something around a circle, and then you're linking them based on a script, right? This will probably take you 3.5 days to do in Illustrator, right? But if you become proficient in Grasshopper, you're able to design something relational that you can test and quickly adapt and produce something like this, right? Because you're coding the relationships, you're not designing each element independently. Helps you work with geometries in a different way. So how do you think about flows through and in a building, and how do you integrate them in the design process? So it helps you kind of work with interesting geometries. And you'll be familiar with some projects designed using Grasshopper, right? So Tower of Light, trust me, there wasn't someone sitting and kind of drawing these holes individually. Something that you develop relationally. And you can see here, there's a gradient, right? So you start to understand through using Grasshopper how to include different logic in your design process. Other examples here of the stadium, and you can see some of the scripts behind it, right? So it's a way for you to develop geometries in a relational way, right? So hopefully that makes sense. You can also use it for environmental analysis, and you can use the outcome of that analysis to drive some of the design aspects. Okay, so hopefully that was a useful overview of why Grasshopper is a different software than what we're used to. So if we're actually going to talk about an interface, you should all have Rhino open by now, right? So I can see most of you have it open. And then on the top right here, there's a green circle with a Grasshopper insect in the middle, right? You press that to launch the Grasshopper plugin. You can also launch it by inputting Grasshopper into the command, right? So Rhino works on a command prompt basis. So you can, similar to AutoCAD, similar to other stuff that you've worked on, so you can type in Grasshopper and it will come up as well. Right, so just to show you here, you should have two interfaces. This is the native Rhino. You click on this and then you get Grasshopper, right? So you get something completely different here, right? You get the canvas. This is where we'll be developing our scripts, okay? Is everything clear for now? Yeah, good. Where am I? Yeah. Okay. So, how does this interaction work between the two interfaces, right? So we have the Rhino interface and we have the Grasshopper interface. What you need to know is whatever you're developing as a script, you're developing in Grasshopper. So anything over here, you see the box with a circle around it, right? This is a node, right? So a node, we'll get into it in a bit, but basically it's an instruction, right? Do something. The nodes have inputs and outputs. The outputs of those nodes usually are shown in the Rhino interface, right? So this comes with a caveat. Not every outcome of a node is a geometry, so you can't see things, right? So if it's a number, it's number 7, you can't see the number 7 in the Rhino, right? But if it's a box, you will be able to see it, okay? So just because you can't see something in Rhino doesn't mean that it doesn't exist or you're not working with it, okay? So, very, very basically, a node is a set of instruction. So, it's inputs and outputs. You give it something, it executes a command based on that something you gave it, and it gives you out something else, right? So very basically, this is a multiplication node. If I give it the number 5 and the number 5, the result will be 25, okay? So you can see here, yeah? Very simply. So I'll show you quickly here, just to drive it home. So here, if I do, you can follow me if you want. So if I type in, if I double click on the canvas, type in multiplication, and then double click again, type number 5, double click again, type number 5. You should have 2 sliders and one node. So double click on the canvas, type multiplication. Yeah, so here, double click, you'll get a prompt. And then you just type in multiplication, okay? So if I double click type number 5, I get what's called a slider, right? So it's a form of input. Slider is basically a number that I can change based on a range, okay? I want you to double click again and type in panel. Right? Sliders. Yeah, we'll have 2 sliders with no panel. Yeah, just random items for now. Yeah? Have you installed Rhino? Have you opened Grasshopper? Okay, so I have my instruction here, right? So if I hover over my instruction, it will say multiplication, A times B, right? So A is input 1, B is input 2, and I can see there's two semicircles here, right? So anything on the left of the node is an input, anything on the right is an output, okay? So if I was to connect 5 as an input, the other one 5 as an input, and then use the panel to read the output, so the wires here are indicating where the flow of information is, okay? I can see that makes sense, right? 5 times 5 is 25, okay? Any questions about this? Again, we need to make sure everyone's not getting lost here, right? So, any questions? No? Yes? If you double click, you can type in slider or 5. Just type in 5. And then do another. Right, so if I was to go back, because I know this is a slider I can change, if I was to change this to 2, you'll see whenever I change an input, the node automatically applies the instruction, right? So if I leave this as it is, it'll always be 2 times 5, right? Which is 10. If I change this, because I changed the input, the instruction is going to update, and it's going to update based on the new information I give it, right? So 3 times 5 is 15, okay? So this is how you've actually coded your first programming script, by the way, right? So congratulations. A very dumb calculator. So we're going to make some interesting things. Does that make sense, right? So I know the edges connect information, yeah? And you want to think of it, inputs and outputs, yeah? So close this. Type in multiplication. Yeah? There's no license, just follow the work. So these slides are on Moodle, by the way, so you'll be able to find them later, okay? So the instruction, which is the node, sometimes won't work, right? For reasons which are probably your fault. So if you go on Grasshopper again, and let's create a new panel. So let's create a new panel like this, an empty panel. So a panel is a way for us to read some of the outcomes. So you see how I've connected it here initially, yeah? So I can read what the outcome is, 15, yeah? Because this is the outcome node. By the way, you connect the nodes, you connect them by dragging and dropping like this, right? Yeah. But if I double click on this, and let's say I type in 10, don't press enter, type in 10 and then click out. I can also use it as an input, right? Here. So in this case, I created the panel, I put in the number 10, and then I used it as an input rather than a way to read outputs, okay? So here this also works, 3 times 10, 4 times 10, and you can see it keeps on updating here. I can try something else, right? So I can try doing duck, just a random thing, right? This is not gonna work. I can try doing, I can try doing other stuff like -1. So here, this also works. 6 times -1 is -1. Although I didn't expect this to work, but if I multiply 6 by duck, I get 6. So what's doing? So this is part of understanding how the script works, right? I can tell that this instruction is not really considering B as an outcome. So yeah, so if you go here, sometimes the node changes color, right? And it's changing color to indicate something, right? So sometimes it'll turn orange, and that's giving you a warning, saying basically, I kind of can't figure out, but something wrong. Red means error, right? So you see in this example here, I'm trying to multiply 5 by a geometry. And it's turning red saying there's an error and it's not giving me an outcome, right? So how do you times 5 by a rectangle, for example? Right? It doesn't work. And if it works fine, usually it doesn't change the color at all, right? So there's something else to consider, right? So we're going to be developing some things which are more complicated, not just based on one number, right? Because who needs a small multiplication node? Sometimes you'll have lists, right? So the input doesn't have to be one item. It can be a collection of items, right? So in this case, if you can see closely, 5 goes into the input A, 5 and 10, right? So this is a list of 2 items. 2 of them are numbers. This is a list of 2 items, 2 of them numbers, right? So the basic principle, and then we'll cover this in a later Grasshopper workshop in the future, but the basic principle is that the index, so you see here 0, 1, so the list starts in 0 in Grasshopper, they correspond to each other. So 5 gets multiplied by 5, giving me 25. 10 gets multiplied by 2, giving me 20. So I can have lists of things, and I don't have to go separate them out, multiply them, and put them back in. I can do them in one go, right? If I know they correspond, and I want to figure out what the first item multiplied by the second item is, I can just give them a list. Okay? So we're going to be working with lists today, so this is something to be aware of. Okay? I'll get into that later. Sometimes the lists don't correspond, right? So you might have a list of 1 item, and you might have a list of 2 items, right? So in this case, 5 gets multiplied by 5, 5 by 5, 10 by 2, like we just said, which gives me a list. But if we have 2 lists that are different sizes, the last item on the list is going to be multiplied by whatever's left, right? So here, 5 gets times by 5 is 25, and because we don't have any more items, 5 gets multiplied by 10 as well, right? So what I'm saying is use panels effectively in your process, because they'll help you debug, will help you understand what the instruction is doing, okay? Because sometimes you might get something unexpected as an outcome, but you have to kind of figure out based on you have to map the input and output. Okay, so I'm sure everyone's thinking, why are we multiplying numbers and we're not? What's architecture got to do with this? Right? What's the basis of geometry? How do you represent the points? This is a question, by the way. Value? A point, how do you represent a point? Coordinates, how many values in a coordinate? 3. Good. So every single thing we're working with fundamentally is a list of numbers somehow. Okay? So how do you represent a line? It's 2 points. Okay? How do you represent the surface? Surface is made out of 4 edges, right? So 4 lines. Okay? How do you represent the volume? The volume is the surface extracted or extruded. Okay? So when we're working with numbers, it's directly related to working with geometry. Okay? Because if I was to go in Grasshopper now, I want to create a point, right? So, by the way, there's lots of nodes, right? And they're separated into categories here. A lot of them are more complicated than others, but you can spend the time looking through them. Today, I'm just going to be telling you which ones to use because I know them, okay? But through time, you'll develop it, right? But if you understand that things are made out of other things, you'll be able to build some interesting stuff, okay? So let's create a point, right? Point 3 PT. Okay, so we need this node here, construct point. Okay, so we already said a point is made out of 3 values, right? Because otherwise, where do you position a point in space? Okay. So, PT, you can see see the inputs are X, Y, and Z. Okay? So I want you to create 3 different sliders, 3 different numbers, and create the points. Okay? So it's a very simple task. 3 sliders, use them as inputs, and then see what you get out of it. So once you've done that, I want you to change the sliders and see what you get in Rhino. Okay? Oh, you should have seen my previous laptop. You should have seen my previous one. Yeah.
I have it here. I was checking both. They all have bifocals installed. Should I tell them to?
I think I have bifocals.
You have it? Search for it by tapping, but
maybe not.
But I can
Draw,
tell,
I can do draw full
to
names.
type bifocals and just leave it there.
I can do full names. This is
As they prefer.
I think
But they will have it installed, so they could potentially just
yeah.
have it and keep the shortcuts.
Yeah. So your nodes might look a bit different, right? So if you want to have the full text here, just go on View, and then not View, Display, and then draw full names, right? It'll change from this to this, right? It's a visual thing, doesn't change anything else. Who hasn't been able to create a point? No? Yeah, we'll make points. Make a circle. Wow. Yeah. So if you move the Grasshopper interface slightly out, you should see that you have a red dot appear, right? Yeah? Can everyone see a red dot? So this red dot is a point that we just created. By the way, it's phantom, right? I can't select it in Rhino. Rhino doesn't recognize it, right? It's like a demon possessing Rhino. Okay? So because it's red indicates that it's geometry that we have in Rhino. So if you click on the node, it'll turn green. Okay? Yeah? So this is how we know which nodes are responsible for which geometry. So if I click on this, it turns green, which means I've selected this point, and the representation of it is in Rhino. Yeah? And then you can move this around, and you can see the point, starts moving, right? So what we're doing is we're controlling the position of the points based on the 3 values. Okay? Yeah?
Everyone, if you have questions or stuff, just raise your hand. I'm walking around, so I'll be happy to.
So a slider is a node, right? A type of node is called an input node. So it doesn't have any inputs, it just gives you outputs, right? So if you want to increase, so I have a slider that goes up to 100 here. You can double click on number slider, and then it has parameters here, right? So it has a minimum, maximum value. I can change that as much as I want. So you're not limited by 0 to 10. I can even make them into decimals, yeah? So use real points, and then hopefully you can see now, it's 23.880, right? It's just an input that gives you a number, nothing else. Yeah? I want you to select the point, Control C, Control V. Just copy it underneath. Drag it down. Yeah, so when you click on a node, it turns green. When it turns green, you can move it. Yeah. So how many points do you have now in Grasshopper? 2 points. Well, we only see 1. Yeah. So the reason we can only see 1 is because they have the exact same inputs, right? So this point is exactly the same location as this point, so it looks like all points. So I can move it around a bit just to differentiate, yeah. There, and we said, we talked about lines earlier. How do you make a line? A line is the shortest distance between 2 points. Okay? So if I type in line, this one, yeah, this one here, and then I can connect the first point to the second point. Now I have a line basically that I can control parametrically. Yeah. Yeah. So every time I change an input, all the nodes from left to right get recomputed. Yeah. There's only one line. Okay, so you want the one. So so here you want this one, right? You don't want the one underneath. You don't want the one in a black hexagon. Yeah, the one above. Okay. So is everyone following? Have you created lines and everything here? No, if you haven't. Okay, good point. Yeah, so on your canvas, that's why you need a mouse if you're working with Grasshopper. Zoom in and out using the wheel, right? And you right click to pan around. Yeah. So hopefully this makes sense, right? So the whole logic of Grasshopper works from left to right, inputs, outputs leading into inputs, leading into outputs, right? So I can do stuff like extrude. Now I can create a surface. You don't have to follow me here, but I just want to demonstrate. From a line, I can create a surface, right? So, and all of these are only controlled by my 4 initial points. So whenever I change something, everything gets re-executed, okay? So hopefully you can see that components build on each other, okay? So it's a hierarchical, and it works from left to right. Okay. You can see here I have an example on the slide. So we start off with 4 points. We create 2 lines, we create a surface between the lines, and then by extruding the surface, we get a volume. Right? So it's very methodical, very logical, and everything follows. Right? So if I go back, change anything from the beginning, everything gets re-executed. Okay. Yeah?
In this case,
Yeah.
is it trimmed surface or not?
This one's untrimmed.
And extrusion is untrimmed.
Extrusion is untrimmed, yeah. Loft is untrimmed, and extrusion is untrimmed. So we'll get into that later. Okay. So we want to step back now, talk about something else. Okay. So what we just produced now is something relational, right? Does anyone know what the difference between mesh and NURBS modeling is? Right? So this is homework for you to do, right? But I'm just telling you now because it's something important to know. Basically, there's two general types to modeling. Okay, one of them is called mesh modeling, and one of them is called NURBS modeling. NURBS is non-uniform rational beats lines. So NURBS is a mathematical calculation. So why is Rhino so powerful as a tool? Is because the geometry is generated mathematically. Right? That's why you get infinitely smooth surfaces in Rhino. You're all familiar with SketchUp and how annoying it is when you try to do something smooth, right? It gets triangulated. That's because it works with mesh. Mesh basically, it works with triangle as a basic geometry. It doesn't work with curves. Right? So a surface or a sphere in SketchUp is basically made out of a lot of triangles. A sphere in Rhino is one surface. No, it's not segmented in any way. Okay? So I'm going to show you this now, just to illustrate. So by the way, if you want to turn this off temporarily, click on this green one. Yeah? Click on this green one, you'll turn off everything here, right? It still exists. Still exists in Grasshopper if I select it. But if I have nothing selected, it doesn't show up, okay? So if I was to go here and create a sphere, this is what I get, right? It doesn't look much of a sphere. It just looks like 3 circles, right? And this is because it's in a specific view, right? So if I go and shade it, you see I have a sphere, okay? We can all agree this is a very, very nice sphere, right? Like it's even shining, right? So you can imagine how smooth it is. The reason you don't see the edges is theoretically they don't exist, because what we're seeing now is mathematically generated, okay? So that's why when you go on wireframe, it only gives you the edges. And you'll only have one seam, right? So if you can see here, this dark line, that's called a seam. If you go and shade it, it makes it a bit clearer. It's because this is all one surface that's wrapped into a sphere, right? It's not segmented. It's not made out of a lot of different triangles, right? So if I go here and create a surface, you'll get the same thing, right? So does anyone know what these lines here are in the middle? Why? You know, when you first use Rhino, they're very annoying. Like, what the hell are you? What's the point? Huh? Isocurves, yeah. So those lines are very interesting, and this is where the power of Grasshopper and Rhino come in. These lines represent the local coordinates. Okay? So if I was to try to figure out where the midpoint of this is, I already know here. Right? So these are not really good lines. It's telling me this is the surface, right? And this is the local coordinates. Okay? Same here. These lines around are not really segments of any one surface. Just showing you a little. Does that make sense? Yeah? It doesn't let me know. No one's asking questions. So. Huh? Okay. Okay, sure. Yeah. You need some help. Okay. So I'll show you some interesting manipulations, right? So we have 2 different geometries here. The one on the right, the one on the right is a mesh geometry. So I just turned it into a mesh. So you can see it's made out of a lot of different surfaces. So if I zoom in, you can see the straight lines, right? This one, I can zoom in as much as I want. I wouldn't find these straight lines. So, and this is very powerful, right? So because this is mathematical, I can do some interesting manipulations, right? So if I use the command rebuild, you can ignore this for now. Whenever I try to manipulate it, it gets manipulated as one thing. Okay? And then if I do, so this still remains one solid object, still shiny because it's smooth. But you see the local coordinates have changed because I've stretched it. Okay? So hopefully that makes sense. This one, I cannot do the same thing, right? So here, if I try to do the same thing, it's gonna pretend to be SketchUp. Okay? So mesh versus NURBS is something you should all really know if you really want to start modeling. Okay? And I want you to really think about this local coordinate system, which is a very powerful thing for NURBS, because we're going to be using it later as well, right? So if you want to segment the surface, we can segment it based on coordinates, rather than going and measuring everything and trying to divide it. Okay? So you see it's very, very, very stretchy versus very rigid. Okay? All right. One more thing. So I mentioned input components. So a slider is one, right? No, not this one. This is an input component. I can use a panel. So I showed this earlier. So panel, right? I can use this to input geometry. But how do I? So Rhino and Grasshopper can interact, right? It doesn't. It's not the case that everything I do in Grasshopper then gets translated into Rhino. I can bring things from Rhino into Grasshopper, right? So if you go, and I want you all to follow this now. So if you go delete whatever you had, you see this point. So if you right click is a single point. If you right click is multiple points. If you left click is a single point. We want to right click, and we want to just draw, let's say 5 points. Okay. Have you got 5 points? Yeah. So very simple. How do I bring those 5 points into Grasshopper? I use something called a container node. Container node is exactly what it's named. It's a container, it holds something. Yeah. And these, you'll find these in these parameters, right? So we mentioned earlier a hexagon. So a black hexagon indicates the container node. And you'll find they'll have different icons, right? So we already talked about what a line is, what a point is. Each one of these container nodes can contain a certain geometry. You can't contain everything. Okay? So I have 5 points I want to bring into Grasshopper. I would want to use a point container node, right? So this one's here, points. And you can see it's a very small one like this. Okay? So I don't really need the nodes at the beginning. You can keep it if you want, but I'm just deleting it to make things clear. So I mentioned earlier that nodes can change color, right? So this one is complaining. I need to figure out why it's complaining. It says floating parameter point failed to collect data. Okay? So it's saying I don't have any data. What do you want me to do? So a container node, you can basically use it as as steps within to kind of contain your data in Grasshopper, but you can also use it to reference Rhino geometry. So if I right click, set multiple points, I should have these points, and you can see they're green now, which means they're in Grasshopper. Okay? So there's 2 ways to do this. So it's complaining, it's orange, it doesn't have any data. I can select them all and then right click, select multiple points. Or if I don't have them selected, I can go right click, select multiple points, and then select them in Rhino. And then press enter. Okay. Does everyone have these? Yeah. So your points in Rhino should be highlighted in green, right? So if I move anything in Rhino, it updates straight away in Grasshopper, right? Because I can see the green points, right? Which means this is being updated. Okay. Yeah. Points. Yeah, points container node. You can delete everything else you have, you don't need it. Okay. Right click, set multiple points. So I mentioned earlier that NURBS is based on mathematics. Okay? How do you think a curve is represented mathematically? Has anyone got? It's a tough question, right? I don't expect you to know, but guess it. Yeah?
It would be like 2 points in a radius.
2 points in the radius. Good one. Yeah. Any other thoughts?
Isn't that
That would be an arc, right? Yeah, which is right. It's a curve. So you have 1 point, you have a second point, and then you have a radius to show where the curve is. Okay. Any other clues?
isn't that dependent on what kind of curve?
Yeah. So this one's a NURBS curve. Are you saying? Yeah. I'll talk about that. So NURBS modeling, to create curves, you use 2 different parameters. Okay. Something called the degree I don't want to get into it now, okay? And something called points. Right? We're all familiar with points. So if I go here, interpolate, yeah, it's another node. The action of interpolate is to, if you hover over, it'll tell you, right? So here it says create an interpolated curve through a set of points. Okay. So if I give it the points, you should see this. Okay. So to create this curve, all we really needed now is 5 points, right? We can have more than 5 points. We can have 7 points. 3 points. We want. Don't have too many points. Then it becomes So again, this is part of the homework, right? But so if I was to show you this image here, the green points are the points we're using to create the surface, and this is mathematically. So the distance between so degrees is the amount of points it's considering to generate the curve, right? It's not very complicated mathematics, but it's worth you knowing, right? So this curve isn't just random. We're actually controlling it through points, okay? And you can see the same thing here, what we did with the manipulation of the circle earlier. What we're doing is almost like a cage we're changing, and the geometry is generated within. Okay? So, if we go here, this is the same thing, right? We have vertices, degrees. So this one, if I give it 1 degree, which means do not segregate or only consider the 1 point, it gives me a segmented curve. Yeah? If I say consider the 2 points, it's going to give me a smoother curve, right? So that's related to the equation of how it generates the curve. Okay? Does that make sense? Trust me, all this will help you later on, although it seems a bit technical, but yeah. And there's three degrees as well, but anyway. Periodic. Does anyone know what this does? Periodic? Sorry? So what kind of data types did we work with? Yeah? What kind of data types did we work with? We worked with the point. Point is the data type. What else did we work with? The number. Number is the data type. Point is not number. We worked with something called a string or text. So there's four very basic data types you should all know, which is a number, something called the float, which is a decimal number, something called the Boolean. Does anyone know what the Boolean is? Yeah. Boolean is true or false. Okay. So we have this instruction. We want to create a curve from points. At the moment, it's not a surface, it's open, right? On one end. So saying periodic, if you go on the periodic, hover over it. And you'll have to know how to read these nodes, right? So if you hover over, do you see the black hexagon turn up again? Yeah? The black hexagon here? With a half a circle, white? Yeah? No? Can I get some people? Yes? So, does anyone know what this means whenever you're hovering over an input? This one. Yes. It's telling you what type of data type it's expecting. Okay? Right? So, whenever you're hovering over an input, it will tell you what kind of data type it needs. Okay? So, if we go back to the params, which we mentioned earlier, hover over here, it says Boolean. Boolean is a data type, okay? So these are the four basic ones I mentioned, right? So text, these are very basic, right? So we're not talking about geometry, we're talking about the fundamental data types, okay? We have a number, we have an integer, so a number has decimals, an integer doesn't. An integer is 1, 2, 3, a number is 0.5, okay? And we have a Boolean. Boolean is a true or false value. So if I double click, type in Boolean. Boolean, by the way, is the name of the person who invented the data type, whatever. Yeah? So we get this. So we have another type of input. Right? It says false. We can double click, and now it says true. Yeah? Double click false, double click true. I want you to connect that to the periodic. So by the way, I forgot to mention, if you want to disconnect, you hold down Control, and then you connect. Okay? So if you want to disconnect, if you can connect by dragging, you can disconnect by dragging the same motion, but holding down Control, it'll disconnect. Yeah? Or you can right click on the inputs, and then disconnect Boolean. Right? So, do we know what periodic does now? Yeah? Has everyone figured it out? Yeah? We need Boolean. Last container, we want to delete that. Yeah. Boolean total. Yeah? So, Boolean total is the input, right? We're not looking for a container, we're looking for an input container. So what has it done? Close it, yeah. So periodic means, give me a true or false value. Do you want the curve closed or do you want it open? Okay? So now we have this closed curve, right? We can move it in different ways. Yeah? Do you understand what the Boolean data type is? Yeah? So true or false? Huh? True or false? Yeah? So you hover over here. So you have 10 points. So you managed to reference the same point twice. Okay. So I'll show you. Go right now. Come on. Right, so.
One question.
Yes. How do you disconnect? So again, if you want to disconnect, same motion, but hold down Control. So you see how the arrow is changing? Control, disconnect. Yeah. So now we have 5 points in Rhino. We've created a curve from them. Okay. So now we want to create a surface from the curves. So again, we're building it up, right? So we have to start somewhere. We always start from a number, typically. Yeah. This is one of the useful things with container. Sometimes there's a shortcut, right? And this only comes from experience. But a curve, if you have a flat curve, and you link it to a container node, so a container node can take inputs as well, right? It's basically understanding that we have a curve and we want to generate a surface from it. So it's giving that, right? Giving that surface for us. So if you just type in surface, you need this container node, right? Here, surface. Yep. It's not going to work. It has, so you can try this, right? So move one of them Z up. It's not going to work. So we have to build it in a different way. Because it's not plain now. It's to be plain. Okay, so let's pretend this is a floor plate for a tower we want to design. Okay, a tower is made out of more than one floor plate, obviously. What we want to do is copy this floor plate number of times using a set number of distances. Okay, so you want to take one, almost like a pancake, one on top of the other, on top of the other. So how do we do that? Right. So in Grasshopper you have geometries, but you also have ways to manipulate geometries. Okay? So one of the ways to manipulate geometries is by rotating them, scaling them, moving them. Okay? Move it anywhere you want. Okay? So, I mean, I indicated what it is, right? We want to use something called move, the move mode. Okay? So if you type in move and you get it up. Sorry? Control, it should work. Is it not working for everyone? Control? It's working. Maybe you got FN. So whenever you're doing control, it's from the input to the output. Okay? So if you want to scan this, yeah, so you can right click here. And then so an easier way is to right-click disconnect here, right? So sometimes you might have a lot of inputs, and you can just disconnect from here. Okay. Right. So move. Let's see what move does. So translate, move an object along a vector. Okay. Does anyone take in mathematics? Remember back in the days when it's vectors? Remember what vectors? Yeah. What's the vector? Direction and magnitude. It's not a geometry. The vector is not a geometry, it's a force. Okay? So, if we're going to move something by a vector, we need to move it in a certain direction and in a certain distance, magnitude. Okay? So we want to create a vector. Okay? Again, a vector is not a geometry, it's a force. Right? So we won't see it in Grasshopper because it doesn't have a location. But we can use it to move stuff. Okay? So we can go here. Construct vector. Vector XYZ. Again, with time you'll be familiar with all the different components, but we're just learning the workflow today. Okay? Vector XYZ, so it's telling me we're designing a tower, right? So we don't want to move anything in the X and Y. We just want to move it up. Okay? Vertical. So we can bring our sliders. We can use a 0. We don't care about X and Y. We can use the same slider for both. And then so this all depends how you modeled your geometry, right? So if I was to go on Rhino here and just quickly look at how big, because we didn't model this considering dimensions, right? Which is a good idea to do, by the way, from the beginning, okay? But the size of, so this is 10 millimeters wide, roughly, okay? So if I was to move it in the Z direction, 10,000, right? So 10 meters. If I was to move it in the Z direction up 10 meters, I can start working with that, right? So I can start by putting in 10, 1, 2, 3, so 10,000. And then connect it to Z, right? And then if I get a panel out, I can see I have 3 values. So a vector is represented in the same way as a point is. So a vector is represented in the same way a point is. But a point shows us a location, right? A vector shows us a magnitude. So the 1,000 here isn't the location of something. It's actually how far you want something to move. Okay? So 1,000 units in the Z. It can be anywhere, as long as 1,000 units in the Z. Okay? So now we have a vector. If we hover over motion, we should be able to understand now how we're building this. Okay? So you can see a black hexagon with an arrow is asking for a vector. Okay? Here, vector, geometry, self-explanatory. What do you want to move? Give me what you want to move, and give me the magnitude, and I'll move it for you. Right? Okay, so we want to move the surface using our vector. Okay, so this is what we have. And you can see you can start changing this, right? So you can move this up and down. You can say, okay, I want it to be 3.6 meters or 3 meters instead. Yeah? Does that make sense? So, who knows, and this is for the people who haven't used Grasshopper before, who knows how we can create multiple surfaces without replicating all this again and adding it to that? How do we create multiple layers for our counter? I mentioned this earlier when I said you have to pay attention to the lists. Okay? How does it work, right? We need to start thinking about lists and why lists are important. So there's a lot of new things you're learning here, right? It's completely different software. So some of you are asking me, why is it moved before I've given it a vector? Right? So if you go and disconnect motion, motion. If you hover over motion, there's something here, important bit of information we missed, right? So sometimes you don't have to give it an input, okay? Because there's a default value. So if you look here, if you hover over motion, it says 0, 0, 10, which means the default value is 10. So if you don't give it a vector, it'll just move it by 10. Yeah? Okay? So can you see that here? Hover over motion, 0, 0, 10. This is the default value. I didn't give it any vector. Right? So some of you might have seen 2 layers. Okay. Has anyone thought about how we can create an array and multiply this? Huh? Multiply? So if I take a surface, multiply it by 5, it's just going to automatically. I need the direction, I need the distance, I need. Yeah? How many? There's a lot of things, right? How do I move the geometry multiple times? So, in simple terms, I need a vector for each surface I'm moving. Okay? So if I go here, and this is why working with numbers is important and why we started off with it, right? I want to create a series of vectors. Okay? How do you create a series of vectors? We need to start off with a series of values. Okay? So we use a component called series here. Again, we can see default values, right? So we can see the start says 0. That's the default value, right? Step. And then we have count. So if we want to create a series, so let's connect the panel to it. Panel. This is something you have to get used to. Numbers always start from 0, right? So this is 10 values from 0 to 9. It's not 10 values from 1 to 10. Okay? So you count 0, 1, 2. Take some useful, but you'll get handled. Yeah. So I know now that 3,000 3,000 is what the step is. So if I was to create a tower with 3,000 in between, I want the 3,000 to be a step. So I start off with 3,000, 0, 3,000, 6,000, okay, and so on. So my step is 3,000. I want a tower with 10 stories, right? So I need 10 counts, and I need to start off from 0, okay? So hopefully it's making sense, yeah? So a series, 0, 3, 6,000, 8, 9,000, so on. All right, yeah. So it's basically a way for you to generate a list of numbers that you can control. So it's just a list of numbers now, nothing else. Because how do you create a vector? We said you create it using numbers, right? So we're creating the Z values. So, where do we input this list of numbers? Does anyone know? Remember we talked about lists and how they work together? Yeah? No. Close? No. But we already have it there, by the way, right? We already have the input there somewhere. Huh? Which one? Which input? Huh? Which one? Oh, the name of the input. Z. Yes. So if I give a list of Z values to a vector component, I'm going to get the same size output of vectors. Right? So we said this earlier, right? So at the moment, I'm creating one vector because I have 3 values, x, y, and z. If I bring this over here and I have a list of 10 vectors, you see how it automatically worked, right? So my outcome is 10 vectors, and I'm applying those 10 vectors to my surface. So it's going to move it once 0, once 300, once 600. Okay? So you see, we're not really, all we have is 1, 2, 3. We have 4 nodes, right? I'm already dealing with something interesting. Yeah? Does that make sense? So we're creating 10 vectors, and we're applying it to a surface. Yeah? So, although this has one value, because we have 10 values here, each of these 10 values are going to borrow from these 1 values. Okay? Ask me questions if you are not clear. Yes? Huh? So you see the very intense red. It means everything is so close to each other. 3,000 bits, but your distance, this distance is going to be changes to 10. So you all have different scales, right? Just keep that in mind. Yeah. If the size of the building is 5 millimeters, you don't multiply it by 10,000 millimeters, right? So just keep the inputs in mind. So, if we look at our outcome, we can see now we have a list of 10 surfaces, right? So let's go back and see, kind of try to test the logic we're using, right? So everything is based initially on these points, right? So if I was to go in Rhino, select these, and move them, everything's going to be updated, okay? So everything is executed from the very basic input all the way again whenever we change any parameter, yeah? We can test different size buildings, right? So we can compress it, go up and down. Our building can grow based on the number of levels we add to it, right? So you can see all the list is changing dynamically, yeah? So every time we change something, everything gets updated, yeah? So everything is very, very linked, yeah? Everything has cascades. Okay. How do you make this tower more interesting? Any ideas? Huh? How do you make it more interesting? So, how do we slope the tower a bit? No. Good guess? No. How do we lean the tower a bit? Huh? Closer? No rotation. So something you have, right? So think about this. We're moving things based on a vector. You understand? No, it's right in front of you. You look. Pay attention. Go back. Yes. Y and Z. So if you change the Y and Z, you should see it go like this. Because we're changing the direction of the vector, right? Yeah. So if I go back here and change this, yeah, so it's not gonna work because we need to create a series, right? But just to do it quickly, illustrate it. So if we go here, we want to do the same thing. Let's do this here, like this. Okay. So you can see the list of vectors coming out. They're not 0, 0, Z anymore, right? I'm moving things in the X, not in the Y, but in the Z. Does that make sense? So here I can 0, and the whole thing starts to slant. Yeah. So and you can see hopefully here the vectors are changing. So 0 on the X, this Y value changes based on this. Okay. So if you really know how to use these nodes properly, you can go on and use any plugin you want in Grasshopper, right? The issue is when working with Grasshopper is you're jumping into plugins and not knowing how to use Grasshopper properly, and then you get confused. Yeah? So all these kind of basic things we're doing are very important. Something. So. What else? Do you wanna try something else for your tower? Rotations? Huh? You wanna twist? Okay, let's twist. How do we twist? Huh? Along axis, okay. What else? We need a number by how much we want to rotate, right? So, very basic stuff, right? So, we want to rotate. Yeah? So how do you rotate something? You have an angle and you have a point. Because I can rotate on my axis or I can rotate around her like this. So axis is one of them. Yeah. So we'll get there in a bit. But can you see that if I'm clicking on a certain node, I get the geometries highlighted. I can turn those off by going on enabled, right? Or sorry, not enabled, preview. Yeah? So preview, basically what it does, it hides it, but it's still there because look, we have the data coming out, right? That's the important thing. Yeah? So it's just, for you, if you really want to manage it and it's getting complicated, you can go back and turn these off. So preview, preview. I can turn this back on, preview, right? Okay, so if I want to rotate each surface differently, I'll do the same thing, series, okay? Or I can do random. I can do random, huh?
So every series.
Yeah. So if you twist, yes, effectively yes. So if I twist something. If my tower is inclined, then yes. Okay. But let's keep it simple today. I don't want to overcomplicate it. So my tower is just gonna be in the Z, right? It's not inclined. So I have a geometry, I have an angle, and I have a plane. A plane is the axis you're talking about, right? So this is geometry. I need a node called area. The area is gonna give me the midpoints for each curve. So the area is my axis, effectively. Angle. Rotation angle in radians. Does anyone know what radians are? Radians is a different unit, right? So you can measure an angle using degrees. We all know 360 degrees in a circle. Or you can measure using gradients. So it's just a different unit, right? So just to make it easier for us, we want to use a component called radians, this one. And basically we give it a degree. So let's say if I give it 20 degrees, it's going to give me that in radians, right? So I can go here, give that as an angle. I can give it my geometry, and you can see it's rotated. Yeah. So every node in Grasshopper saves its own geometry. So whenever you're building up, you'll find that there's always overlay like this. Okay. But if I want to turn it off, that's why I showed it to you. You go back and you just do preview off. Okay. Yeah. So this one converts degrees to radians, right? So it's a unit. The rotate command is this one. Just rotate. When you're rotating something, it has to be an axis and a degree. Yeah. So we're giving it the degree based on this, right? So we want. So for example, in this case, it's rotated by 0, and then this is 39, right? So this is the angle. We want it to be rotated. The plane is the axis, right? So if I use the area, I can get the centroid. If I use something called an XY plane, I can get the axis, right? So a point doesn't give me an axis because I can rotate all around the points. But XY plane means XY is stopped. This is the point, so this is the axis. Okay? So I have a plane here. So basically, I'm rotating around an axis here. Okay? Does that make sense? Zoom in. Yeah. So if there's too many geometries, you can start hiding them, right? So preview, 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 right? Just makes it clean and easy to work with. Okay. So we want to do something else now. We're going to use a command called loft. So loft, let's go over it. It says create a lofted surface through a set of section curves. Okay? So lofted surface means if you have curves, we can create a surface from them. Okay? And we have the list of curves here. We can just connect. Okay? And again, if you go back to your very basic stuff, because everything is linked, yeah? everything works together as one thing.
Sorry, I didn't see lots.
So here,
Just
you should have a list of surfaces. You can loft them here. So just loft. Okay. So So remember here, so we're rotating all the surfaces by one number, okay? But if we create a series again, so let's go back here. Let's say I want to rotate each floor by 15 degrees. So 15 is my step. So you see this one? This tells me how many floors I'm using. I want to use the same one here. Because if I'm changing the amount of floors, I want to create the same size list, right? There. So delete that. And you see I have a list 0, 15, right? I can just simply put that into degrees here. And now my building can start dancing. Right? So you see, every floor I'm changing with a different degree, right? So the first one I'm rotating by 10, the second one by 20, third one by 30, okay? So a lot of you will have a lot of overlapping geometries, right? So go back. So something like this. If you just right click and preview off, right? So every node saves its own data, okay? So I can go back and see where everything is. But and because it saves its own data, I need to turn it off, otherwise it'll be overlapped. Too many overlaps. Okay? Okay. So all this hard work and our outcome is only one thing, right? It's one surface. Okay? So remember what I said earlier, right? We're working with nerves. So things have local coordinates. Okay? So this is actually a good thing. So what we have is 10 floors, 10 geometries, and one surface wrapping all of it around using the loft. Okay? So because it's a NURBS geometry, I can start using the coordinates, local coordinate, right? So I can divide the surface very easily. Okay? So what I can do is use something called divide. Divide domain. Here. What does domain mean? Domain means the coordinates on my surface, right? So what I need to do is link this surface to domain. And if you hover over domain, you can see it says 0 to 3,300, whatever, right? So it's giving me a local coordinate for that surface. Okay? It's a very powerful tool because I can start dividing it in interesting ways. Yeah? U count, V count, this is like the X and Y. So if I'm dividing something, how many do I want to divide it in X? How many times do I want to divide it in Y? Okay? So for now, let's just put 10, 10, and 10. Okay? So 10 and 10. So my outcome here is not geometry, so you wouldn't see anything. My outcome here is coordinates, right? So hopefully you can see the hexagon again. It has the grid, and that grid represents the coordinate data type, right? So it says 100 values. The first one is coordinate 0 to blah. Second one is coordinate 0 to blah, blah. So it's giving me local divisions as numbers, not as geometry. Yeah? So what I'm asking it to do is give me the coordinates if I want to divide it 10 by 10. And then I use something called an isotrim. Isotrim is asking me for a surface. This is not a surface. These are numbers. These are domains. So, sorry, this is the wrong one. I'm looking for isotrim, this one. So it's asking me for the domain, which is this, right? I can see it's the same data type, yeah, because of the hexagon there. And it's asking me for the surface, okay? So there. So now, you should be able to see, I want to preview these off. Should be able to see that I have this surface that's divided 10 in one direction, 10 in the other direction.
Did you just create 100 surfaces?
Sorry?
Did you create 100 surfaces?
Yes. 100 surfaces by dividing x and y. Yeah. So if I was to change this to 5, you can see now this has got bigger, right? So now I've created 50 surfaces. Right? And again, everything's in Rhino, so I can go back, change this is updated automatically, right? Your script should be updating, shouldn't have any issues, right? So you can see I can twist it. Someone wanted to twist their tower there. I can still, if you did it right, I can still change the number of floors, okay? All this, the data is still here. So if I hover over the output, I can still see it has an output, but I've turned the preview off because too many overlapping geometries is too much, okay? So I've went from one untrimmed surface to 50 untrimmed surfaces. Yeah. So sorry, get rid of isotrim. I want you to use a different one. Okay. So I can, if I want to take anything from Grasshopper back into Rhino, I do something called bake, right? So if I right click, bake, click OK, all this geometry I've been working on in Grasshopper then gets translated into Rhino, right? So you can see we're already can get something out of it, okay? So that's just a side thing, just to show you that we're working towards something. Okay. Bake, so anything here, right? So if I want to bake this, I can go I can go here, bake, okay? And you can see this one surface right here, right? This is not divided, by the way, this is just coordinates, okay? You can tell from the thickness of the edge. Okay. So we'll leave this aside. I want you to use something called a surface box. So this one here. I want to connect it to the loft as the surface. I have my domains here. And what you basically see here is based on the surface I created, I can turn it into a surface with some boxes, right? I'll show you why this is useful in a moment, okay? But all I want you to do is now create a surface box. So basically we're taking our surface, we're dividing it using the domain, and then we're creating boxes on the surface, right? So we're taking it from something organic to something that we can put something in. So, it looks like you're pretty much there, right? But we need to finish the workshop, otherwise we're going to stay here for a long time. So some of you, if I was to open this, all of you have arrived here pretty much, right? So what does isotrim do? It takes our smooth surface and divides it, okay? So if I go back here, these are all smooth surfaces I can delete in Rhino, okay? You don't have to do this. So this one is very different, okay? So why would we use a surface box? Basically, we can take geometries and map them on a surface. And that's why we use surface box. So it might look rigid now, but this helps us to achieve something else. So if you go, let's say you go on Rhino now. I want you just to create just go on the top here, and just create a shape like this, right? Just a basic shape. It doesn't have to be like this, just any shape. Yeah? Just a line, clean line, that's closed off. Not too complicated. Then you should all know how to use Rhino, but if you want to extrude, you can just extrude like this. Extrude surface. Extrude curve, sorry. Extrude curve. Enter. So you can create something like this. You can delete the original curve. And then I want you to cap, right? So just the command cap. Basically what it does, it creates it into a volume with no holes, okay? So just something like this, very basic object. Okay? So, that's it. Shall I give you 2 more minutes, or are we? No? No, this is still in NURBS. So you can see the local geometries here. Here. Something else called trimmed and untrimmed surfaces, but you can figure that out later. It's too much to explain today. So just a very basic object, and we want to reference it back into Grasshopper, right? So something else to kind of be mindful of is when you click on something on Rhino, it tells you what it is on the top. This is very useful, right? So if I have a point, if I select a point, it tells me 1 point added to selection, right? If I have a surface, it tells me 1 surface. Again, we talked about how this is 1 surface, yeah? This is a poly surface, so it's made out of multiple surfaces, right? So these types of objects, you'll use something called the B-rep in Grasshopper. B-rep means boundary representation, so basically anything that's mesh or anything that's poly surface. Yeah, pretty much. So you can reference it. So right click, set 1 rep, you've selected it, and now you can see it turns green once we click here, right? And by the way, these slides are on Moodle, and if you go down, it basically has a step-by-step tutorial, right? So if you missed anything today, you can go back here, and it shows you how to do it again, okay? So we all are somewhere here, right? So we all created our pretty kind of pasta objects, right? Fasuli or whatever. And this is what box morph does, right? So you can take an object and apply it in a box frame, yeah? So that's why we're dividing the surface into box. So here we use a command called box morph. Box morph. Yeah. So box morph an object into a twisted box. So we can have an object and basically plot it in the box so it takes shape. Just one more thing before I forget, a few of you mentioned, but I already forgot. So here, some of you will have the boxes on the inside, some of you on the outside. Yeah, is that the case? And that's because surfaces, so in my case, my surface is on the inside, right? Because surfaces have a direction. There's a forward, there's a front of a surface and a back of a surface. So it doesn't matter, by the way, for this exercise, but if you're wondering, you can do something called flip surface. So flip, so now you see it's the other way around, right? So basically what I did is I flipped the surface. It doesn't matter, again, just showing you, right? The surface has a direction. I'm getting rid of that to avoid any confusion. Okay, so my box morph is asking for geometry. So what I want to morph. It's asking for a reference. So basically, where is it contained? How is it contained? And it's asking for a target, right? So a reference, so we need a command called bbox, bounding box. Yeah. Here, and we connect our brep to that node, right? So you can see it's created a box that bounds, right? So it fits snugly, right? And because we need this, because this is the box we're actually going to morph, right? So if you think of it as a guide, we're using it to morph. So how do we morph this without having a guide? We can't, okay? So again, this is our object. This is the bounding box. Our bounding box is the reference. Our brep is the geometry. And now it's asking for a target. So I have the object, I have my container, which is the box. Where is the twisted box you want me to put this box, the bounding box in, right? So this is where this comes along, right? So this might take a few seconds, and you should get something like this, right? So you see, it's not just mapped it, it's twisted it, right? And this is why NURBS is so powerful, because you're working with coordinates and mathematics rather than annoying triangles, okay? So you can actually it can apply mathematical operations to things. Okay?
So, which component is responsible for this rotation? Is it twisted?
It doesn't rotate. So I'll show you. Sorry. So this box here, yeah, this box already has a box around it.
Yeah.
Now, if the box had a different orientation, so the arrangement, the order of the surfaces change, the rotation of it changes. Okay.
Yeah.
So let's see if this works, right? So if I do this, it should change. Yeah. You see?
Right.
Because the box is always this direction. It doesn't rotate with the object.
So,
But where I've placed it in the box, it changes.
The object moves within the box rather than the box itself.
Yes. Yeah. The object moves within the box, but the box stays as it is, as a reference. Right?
okay,
So if
the box doesn't have any normals. Like,
the box does. It always has the same normals. But you see, if I change this changed again.
okay, I got
Yeah.
it.
So the reference is the box that stays the same. But if I rotate the object, now if I put it in an angle completely, it's gonna see this is taking time. It's gonna have some interesting. Let's just try to mess it up.
What's gonna happen if you explode it?
The collection. This is gonna crash. This is gonna not understand, right? So I can explode it now, but yeah.
You just
It's like more of like a comment. When
Yeah.
you click on this, only this shows up. How does that work?
I'll show you.
Let us
So-
have your work saved.
yeah.
Let me-
Can you save the grasshopper?
Yeah. I'll show you. No, you save it as well.
Yeah, that's what I was going to ask. So you
Yeah.
say it crashes, but like what happens?
So okay, again, everyone, it's worth doing this now because your computer might not be recovering after this. Okay.
That's what I was
So go on File. So whenever you're saving a Grasshopper script, you're saving it as a separate file. Okay. So I can go back here and open the files later. Okay. This is a different script. But you also want to save the Rhino script if there's anything important there, right? So this was a previous script, for example. I don't care about this one. I'm just showing you. But you want to save this one, right? So same thing. File, save document, save it somewhere. Okay. You always want to save the Rhino, and you always want to save the Grasshopper, and you open them together. Okay. So don't just save Rhino because you lose everything in Grasshopper. So again, each object holds the data, right? So I have to turn these off. I disabled it, but I have to turn this off here. Off. Right? Is that
But for mine, like whenever I don't press this, there's like a red.
Yeah. So it's because this one here.
Oh, this display.
Yeah. So this one. You have this, right?
Yeah.
Yeah.
Okay.
So if you have, again, this is not your fault, right? Everything's new, so I have to repeat it. But here, if I have this mode on, I can only see what I'm clicking on, which is very helpful, right? because I don't have overlaying things. But if I have this off, anything that's previewed will be there, right? So I can go back here and see this again, okay? So it's just a way for you to manage information because it can get a bit too much in Grasshopper. I want you to go back and test if this works. Yeah, should do. You should be able to control the rotation, the number of floors still, right? Sorry, one second. So no, it's in the box. Look. Right. Yeah. Yeah. So this is a relatively simple script, okay? It's very important to make sure your scripts are organized because I promise you, if you open this tomorrow, you wouldn't know what's going on, okay? So you can do this by grouping them together. So you can do Control G, and you can add text as well, right? So here, you can scribble, right? This is for box morphing, right? And you can add notes. Takes in a box and changes it to fit a surface. Okay, so you can add notes. It's always a good idea to be organized because it happened to me so many times in the past. I do something, I wake up the next morning, I'm lost. Okay, so something useful to do. Views.
Let's say,
yeah,
like we're trying to look at this part of the
yeah.
process. Can I say that as a view? Named views,
I don't know, but
right?
it's a good question. I've never found the need to do that personally.
Are you keeping them small?
Yeah, because if you group them, this is almost like saving it, right? So you're always saying this is one view.
Yeah, but
Yeah, and then you can have, but I don't know personally. Maybe there is. It's worth looking at. Okay, so we're finishing off. Okay, so the last thing to do is what we've been doing again. So make sure to save. So simple file save as. Okay, and then just explore your outcome. So go and bake here, and then bake again. Will transfer all the geometries in Rhino and Grasshopper back into Rhino. Okay, so you can go here and look at what you have, right? Right? Cool. So that's it. What we learned today. What are different data types? How do you create a script? Right? So a script always executes from left to right. Making sure you know what the nodes are. You can through the pop-up understand what it does. You can understand what types of inputs it wants to get as well, right? There's a lot of nodes. It'll take you time to be familiar with them, but today you should all know how to use Grasshopper, understand how to develop something as a script. Okay? I'm going to be around for 5 minutes if you have any more questions. Right? But we're finished.